There's over $1 trillion of waste in supply chains today.
The net zero carbon emission is something that corporates are taking very seriously.
To meet these objectives, they're going to have to take into consideration CO2 emissions.
Hi, and welcome back to another episode of Net Zero Carbon. I'm Tyler Cole, your host, and this is the show at FreightWaves where we deep dive on decarbonization, as always, with a lens on freight fuels and energy. Today, I have the pleasure of being joined by Philip Moslener, Corporate VP of Advanced Technologies at Wabtec. Philip, thanks for joining the show.
Thanks for having me. Glad to be here.
I'm excited to dive in. I got to admit, I have a deep background in a lot of current emissions technologies, biofuels, ethanols, and small batteries, but I'm interested to hear from you what's coming next, and specifically within the rail industry, which I know Wabtec has a huge presence in as one of the primary locomotive manufacturers. But enough for me. Let's get your background a little bit. Can I hear some about your role at Wabtec, as well as just an overview of what Wabtec does?
Okay, great. Well, starting with the Wabtec, it originates from George Westinghouse days. In fact, Wabtec is an acronym for Westinghouse Air Brake Technologies. It grew organically over the years, but with mostly through two recent acquisitions, Philly Transportation and G Transportation. We're providers of rail equipment, and in pertaining to this discussion, we mostly freight locomotives. We have over 23,000 locomotives out there in the world, and 1 out of 5 freight locomotive in the world is a Wabtec loco. So we're quite proud of that. We're 27,000 employees, and with this, in my role in the advanced technologies team, we are a central organization that works with new technology and bringing them into our products. Experimenting with them, researching them, and developing solutions to see how we can integrate them. Really 5 areas in the team where we focus on. One is on the cloud platform. We call it Wabtec One Cloud Platform. It's running state-of-the-art containerization and orchestration software, as well as having great user experience depth in there. We also have a group which is working on digital technologies, focusing mostly on automation. Using AI, artificial intelligence, machine learning, and deep learning, IoT, all these devices, all these new technologies, digital technologies, and bringing them and see how we can maximize and utilize them in the best way in our products. We've got product cybersecurity, working on process and tools to develop secure applications across our business. We also have a additive manufacturing team where we mostly focus on metal 3D printing. We have 5 labs. 3 in the US, 1 in India, and we just opened a new one in France this year. And finally, a sustainable solutions group, which are focusing on the next-gen solutions, next-gen propulsions for our products, namely locomotives. And hydrogen is one big part of our work these days.
You probably have the coolest job within the company, if I were going to lay that out. I mean, you get to touch all the fun, new, shiny toys and figure out how to make them work for everybody in the ecosystem.
No, we're having a lot of fun with this, I have to say.
How big is the team that you're working with? How many people?
With full-time employees, got 80 employees, with some contractors as well in the team. So a nice sized team, not too big, not too small, but we can really get some stuff done.
So good. Well, we could deep dive in each one of those pillars separately and have hours of content to get out. We may have to come back to those later, but I want to drill down on the sustainable solution set and talk specifically about some of the propulsion technologies you guys are exploring. Could you tell us a little bit about maybe in general how you're approaching that sector, that solution, and then we can pick 1, 2, or 3, however many we have time for, and go deeper.
Right. So our approach is a stepwise approach, right? We gotta get solutions that make sense for our customers, that they're able to operate in their day-to-day activities, and they got to be economically viable. So and you got to go step by step. So if you take the North American loco, or the freight loco, I should say, not North American loco, the freight loco, we have the Tier 4 locomotive, which is leader in its class in terms of emissions, and we released that in 2015, and we've been working hard at it to make sure we can deliver the same fuel efficiency as we have from previous tiered locomotives. As you know, there's always a trade-off when you try to reduce emissions. So we're really proud to have achieved that, where we have these these very efficient Tier 4 locomotives. That is the current state of the technology today. Next steps for us, where we're going into, we've gone into batteries. That's been clearly announced that, and we're developing that very actively. And then, batteries have, and we can talk about more in depth. Then we've got the biofuels, I should say, biofuel space, where gives us a stepwise approach to reducing carbon. And then eventually we're going to get to hydrogen, and we're working actively on that as well. And then again, in that space, there's tons of options that are open to us.
Really exciting. And I like how you laid that out in the timeline, because it does feel, near term, midterm, long term. And if you were going to rank those, as you said, probably a biofuel near term, battery electric or hybrid somewhere in a medium term, and then hydrogen as a longer term. How does that line up with, I'm not familiar with locomotive like cycles, right? How long you're developing one before that model is kind of cast and then sent out into the market. I know they have long replacement life cycles, right? These are out in the field for decades, but the design and sell of new locomotives, what does that look like, and how does that time with the technology you just mentioned?
It depends on the iteration, right? If it's an adaptation, it could be short. If it's a white sheet of paper, it takes longer. So anywhere, again, between 2 years to 7 years, depending on what are we dealing with, right? But that also includes, we put a lot of effort and energy in making sure these products are reliable. So when we say, hey, a product is ready, it's got to be at the right reliability level. So we calculate that in flies. So flies failure in local years, and we continue to reduce the numbers of road failures that we get, so that we can get a product which the customers can depend on. So it's a continuous work that we do. Not a question of putting a product out there and let it live. It's a continuous improvement. And then to your point, these assets, they live 30, 40, we've seen 50 years, right, in the market, and with different iterations on them, different improvements. But these are long-lasting assets.
Very exciting. Yeah, I think it's, as a consumer, we generally fall into thinking model years of cars, right, as the analog, and that is absolutely not the case in the locomotive sector. Can we talk about what's not on the bench yet? So maybe real briefly what you guys have seen with biofuels. And when I say not on the bench, like what's actually in the wild working biofuels, and maybe some battery electric technologies you guys are out testing. Yeah,
if you start with biofuel, our customers are very interested in biofuel. Why? Because it's with very minimal. I'm going to say minimal. With very small impact on the assets, small impact on the infrastructure, you can get a step into reducing carbon emissions. Right, biodiesel is not exactly diesel, but it's close. It's got some differences. And renewable diesel is also getting closer to the blends that we use. So what we're doing is making sure that if, with some customers, we've got a nice program going on right now, a multi-year program to understand what is the effect of using biodiesel and renewable diesel in these assets. And typically we expect to see impacts on gaskets, hoses, the chemical compatibility, if you will, of these fuels. So that's why I say minimal impact, because once we understand really what happens long term, short term you can use these, but long term, what happens if you put, let's say, a B20, a Bio 20 into a locomotive? With B20 you get 14% of carbon reduction, and here we're talking well to wheel reduction, right? So when we look at carbon reduction, it's not just the tailpipe reduction. You got to really understand the entire cycle of where you get your fuel. So so putting 20% of biodiesel, you get 14% reduction. Very interesting, right? It's a step towards in the right direction. You go to, let's say, B20 R80, so Bio 20 and renewable 80. Well, you're climbing up into the 60% reduction. Again, well to wheel. So those are nice quick wins. There's obviously the discussion about, well, how much how much is the fuel going to be like? Right now, access to the fuel is one of those discussions, and not only if you're going to get access to it, what's the price, and where can you get access to it? So those are all the these discussions that are going on right now. But look, our customers are really interested in this, and that's why we've taken the leap in making sure we understand how this works, and they can continue relying on our assets long term.
Excellent. With some of those blends, I mean, I think you explained the challenges and opportunities there really well. With some of the blends, is some of the hurdle on Wabtec side figuring out what you can warranty, what you can say this is good, and making sure you've done the hours of work and running those locomotives in those blends so that you can make sure it's going to be successful for the client out in the field.
Exactly, and that's our priority. Coming back to reliability, got to be these assets need to work.
Yeah, makes total sense. How are you seeing that compare with, let's move midterm, right? Go battery electric. I know you guys have had some tests, I think out with the BN, maybe on the West Coast doing some stuff. What are you seeing as far as reliability, as far as emission savings?
Yeah, so the battery space is very interesting. Again, a step approach to getting to a full decarbonization. If you understand how locos work, there's a lot of braking activity going on locos every day, going downhill or and going into speed restriction zones and things like that. So today when we brake, we use regenerative braking, right? And that energy that's being generated by the traction motor is actually blown through stacked through grid resistors, and it's converted into heat. That's just waste energy. It's an easy punt to say, listen, let's capture that energy. Just like the on a Prius, right? When you're braking, you recharge your batteries on a hybrid vehicle. So that's what the batteries give you. They give you the ability to capture that waste energy for free. You got to carry those batteries, got to put them on there. But that's a big hit. And during you're referring to the exercise or the demo we did in California between Barstow and Stockton. We demonstrated that we could get 11% fuel savings. That's what we had predicted in that, because it's all about terrain. It's about where you're operating and the regime and all that. So so it really gave us what we wanted or we were looking for. And battery technology in this sense can go up to 30% of fuel saving. So we're quite excited about that, how that works. So and just to understand how we operate these batteries in this condition here is let's say a train is made up of 3 locomotives, right? What you do is you take one locomotive out, you replace it with a battery electric loco, what we call the flex drive, and basically it works as a train on a consist level. So what we're looking at is the entire train fuel savings. That's what we look at. It's not really the individual asset itself. It's really how do they work together. So it's a system. And that's why we have to change our mindset now. And look at this as a system and not just individual units performing on their own. So that's a change of mindset that we need to operate here.
Yeah, systems thinking is lacking in the transportation space in a lot of cases. So I'm glad you mentioned that. I'm glad you described how it works because I wanted you to be able to explain for the listeners that it's not just plug and play diesel for battery, that it's all got to work together. And then the challenge is how do we allocate those savings? How do we talk to customers about that? That's a whole nother. We won't delve into carbon accounting on this call. Let's focus on the tech. So that's exciting. Where is that in progress towards midterm targets of having more of those out in the field?
Well, what's exciting about batteries is that, okay, I gave you one use case here, but in fact, there are a bunch of other use cases. We don't stop at, and like every new technology, what we realize is that actually tomorrow's world is a little more complex than having a single diesel space. So, if you think about batteries, so I gave you like the mainline type of scenario, but there are other scenarios like in yards, switchers, where you want to actually reduce the local pollutants, NOx and PM emissions, so that the environment around the yards get cleaned up. So that's a great use case. In this case, what you do is you actually recharge your switchers just like you would recharge an EV. This would be like the EV type of approach, right? So that's a nice use case in this space, in the EV battery space. Another use case is where we're seeing, other mainline is in the mining space. The moving charging approach, that's very interesting because, the most efficient, if you take a step back and you really try to analyze this, very, very holistically, the best way to bring power to a train, a locomotive is catenary. There's no question about it. Electricity coming in from green power coming from the grid right onto your catenary, down to your pantograph and into your system. That's the best way. But we got 140,000 miles of track in the U.S. Electrifying that it'll be super, super costly. So are there other solutions? That's why battery is exciting in that space. Now, moving charging is something similar to that, if you will. Mining trains, very long mining trains, they get loaded. And as they load, they move like 1-2 miles an hour at a time. So while they're being loaded, let's say 100 cars or 150 cars, well, you have an opportunity to actually charge your loco. So imagine if you have a stretch, 1 or 2 mile stretch of catenary power, which the loco gets a chance to reload and get to destination with that power. So that's an interesting approach that we're looking with some of our customers. So again, batteries, we can try to be original and try to find ways in using them in different fashion to really tailor what the customers need.
Yeah, there is no one size fits all solution, or even within a subsector or a specific technology within that sector. You've got to be very dynamic with how you're building these solutions for customers, which I guess leads us to this longer term view, right? When we're thinking about hydrogen playing a role here, that could be even more specific application wise. So can you dive us into a little bit of what you guys and the team are exploring?
Yeah, so hydrogen is, of course, we're very excited about that. Excited because this is for us I won't say the end game, but close to the end game. It's zero. We're looking towards or tending towards zero carbon. In this space, there are really, I would say, two families of use of hydrogen. One is what we hear a lot about is the fuel cells, right? Where we utilize hydrogen and convert that into electricity through fuel cells. But we also see maybe an interim play. And when I say interim, in real time, this is a very long interim. Which is burning hydrogen in an internal combustion engine. So and the way that works is similar to what we've done with the liquid natural gas project down in Florida East Coast, where you actually have a blend of this alternative fuel, in this case, like LNG, with diesel, and you basically ignite the fuel while you're compressing in the chamber, and the diesel acts as the spark plug, ignites the fuel, and so therefore your alternative fuel reduces your carbon emissions. So in the case of hydrogen, right now we've created we've come into agreements with Argonne National Lab as well as Oak Ridge National Lab to do some research around this. How to do the modeling, the combustion modeling inside the chambers, as well as modeling the entire process with Argonne, and also testing it at Oak Ridge National Lab. So we're excited about that. The work is ongoing, and looking forward to see the results. The way we develop these things in the internal combustion engine, you start with, after you've done all your design analysis, then you go into single cylinder testing, and you try to see whether the behavior and the emissions and everything that you need to test and match your analysis. And then once you're happy with that, made all the tweaks, then you go to multi-cylinder engine testing on a bench, and eventually you go into integrated loco, do your field testing, and so on and so forth. So progressively you get there, but today we're at a stage of single cylinder testing and modeling.
That's got to be so exciting to see that come out of, well, it used to be on paper, now it's coming out of a digital model on the computer, and see that in real life actually getting results out of a combustion test. That's exciting.
It is. And, this technology, again, I call it a step approach because, what we're aiming for right now is 50% blend, 50% diesel, 50% hydrogen. And, using the current technologies that exist. So it's just a question of tweaking them, the similar technology we used in Florida. But then there's R&D being done to actually bump it up to higher levels. But as long as you have a bit of even 1% of diesel, you're still not zero carbon, right? So which brings us.
Did you use renewable diesel in that? Are you guys testing that blending too?
Sorry, which one?
Renewable diesel.
So it's part of the plan. Absolutely.
Exciting.
Yeah,
that's so exciting. I would love to go, beyond that and see what is super long term, but we gotta get there first and get through some of these near term solutions. So let me do this since we're running close on time. I ask everybody that comes on the show, I want to know personally, what motivates you? So when you wake up in the morning, you go to work on your sustainable solutions unit. Why is that important to Philip?
As an engineer, I find this a really exciting time. I mean, you said it. I mean, they actually pay us to play with this stuff, right? We have a massive challenge ahead of us with the global climate crisis. But at the same time, as an engineer, we have all these technologies that we're working with, and fantastic technologies which are being incubated at our disposal. So, to me, to solve the climate crisis, engineers are going to be key to solving the challenge. It's clear because it's all about technology. In fact, I'm going to go a step further. I think engineers, we have the moral duty towards society to solve this issue because, as I say, part of it is a big part of it is technology. Of course, their behaviors and all these things, but it's about technology. And so I think we owe it to society to really work hard and make these solutions which are not only that work, that are reliable, but that are cost effective. That so they can be adopted. And so I think it's important to put that, and it's by making the right decisions towards that. So to your question, like one of the things I constantly remind my team is that we work on things that matter. Not that it only matters to the company and to our customers, obviously, and the entire industry, but mostly it matters to society. It's important what we do here, and people depend on us to actually solve these problems. So to me, there's nothing more exciting than doing that. So that's what motivates me to do that. It matters.
That's so encouraging. A nice little dose of techno optimism that engineers can use their powers for good to save the world. I love this. That's so good. Philip, thank you. Thank you for joining me, for explaining what Wabtec has going on. I'm excited to see a lot of these come out of the lab and start making a difference in the world and reducing emissions and fighting climate crisis for everybody. So thank you and your team for what you're doing and for coming on the show today.
Great. Thanks for having me.